Great. Thanks everyone for tuning in. I'm gonna get started in just a minute. Let's see how we're doing. By the way, this is going out live, so I will be able to answer any questions as we go along. I'll be keeping an eye on the chat. But yeah, thank you everyone. I wanted to start by talking quickly about what exactly RxJS is even for. Why do we need another JavaScript library? So I thought we would talk quickly about JavaScript arrays first. And actually drop me a message in the chat if you can hear me all right. I'm not sure if the audio is coming through fine. Anyway, let's talk about JavaScript arrays. So over time, they've gained additional features, often inspired by functional programming, like map, reduce, filter, and so on. We can think of an array as a sequence of values, right, that we can transform any way we like, picking out the good bits as we go, maybe calling a function for every element matching a condition. These are really, really useful tools. Thanks, guys, in the chat, by the way, guys and girls. These are really useful tools, but we should be aware of two main limitations to this. So first of all, there's a breadth of common programming tasks, which it doesn't make sense to rewrite 100 times, but which haven't made their way into the JavaScript language or browser specifications for various reasons. And this gap is somewhat filled by libraries like Lodash or underscore. And Lodash includes things like intersections, it includes zipping arrays together, taking from an array until some function returns false, and so on. These are really general tasks. They're not specific to a client or a specific problem. But like there's still a second limitation, which Lodash doesn't solve. And that's that we have to be working with arrays. Arrays aren't a lazy type in JavaScript, like they are in some languages like Haskell, which inspired many of their features. What this means is that to do any sort of mapping, filtering, reducing, zipping, and so on, we have to have every element loaded at once. This is synchronous code only, right? We have to wait for everything to be in place before we can start on these interesting operations on sequences of data. So what I want to pitch RxJS as is essentially Lodash for asynchronous sequences of values. And I mean, wow, that's really abstract, right? Asynchronous sequences of values. So I'm going to give you a brief kind of intuition to think about these four things. So you've got synchronous versus asynchronous. So this is more or less, do you wait for the value to be there, or do you just get it at some point in the future and you can do other things in the meantime? Right, so synchronous is waiting, asynchronous is essentially deferring it to some time in the future. And we've also got single values versus multiple values. And that's pretty self-explanatory, right? A single value, a function which returns a single value might just return a number, while a function which returns multiple values might be an array of numbers, or if you're really into your JavaScript, maybe a generator of numbers. For a function to return a single item synchronously, yeah, it can just be a number, right? For it to be return multiple items synchronously, it could be an array of numbers or it can be a generator function. But how about these asynchronous values? For some point in the future, right? For a single value, asynchronously, we can use a promise. And a lot of people have come across promises with things like network requests. But promises can also be used for example, loading a file. If you're trying to load a file in Node.js, it will give you a promise back. For multiple values, we could use a promise which resolves to an array. But that often isn't much good if we want the values over time, right? So this is the fourth case where we want asynchronous values at multiple values, right? We don't want, say for example, if we're handling all of the mouse clicks that we have over 30 seconds, we don't want to just wait till the end of that 30 seconds and then have an array of all the mouse clicks that happened. We want to respond to each one as it comes in. So this is where observables come in. We have an observable of click events. If it helps, you can think of them as something a little bit like a promise which can resolve any number of times. Okay, so let's look at a simple example first of all, to how thinking about streams of data can make things a lot easier. So dive in here. So I have a sort of small app skeleton here. So this is just ReactJS. I've got this this function here called useEffect. Essentially, this, as the comment says, this code is just going to run as soon as this component renders for the first time. So as soon as we have, whoops, as soon as we have this this click to refresh button is on the screen, this code will run. So first of all, we'll essentially, this is just a little bit of React code, but we're just picking out the actual button element. So we haven't written any RxJS so far. This is just picking out the button. So now what we want to do is get the stream of button clicks. So to do this, I'm going to use the RxJS function from event. So ordinarily, you might do something like button.add event listener, and then you might say, you know, on click events, call some function. But for us, we're not going to do this. We're going to use RxJS's inbuilt from event function. And this is essentially the same thing, but it will allow us to get a stream of these click events as opposed to just calling a single function each time. So this expression, we can say this gives us a click stream. So we have a stream of click events from this button. And in order to, and actually I should say, a lot of, we're talking about streams so much in RxJS that it's a little bit of a convention to, instead of writing stream after everything, just use a $sign. Right, dollar signs don't have any special meaning in JavaScript. They can just be part of a variable name. And in this case, it's kind of the convention to have the $sign representing stream. Okay, so we have a stream of clicks. What can we do with it, right? So I'm gonna, what we can do to a stream primarily is to subscribe to it. So I'm gonna say clickstream.subscribe and, oops, and this is just, this subscribe function takes a callback, which will take a click event, and we can console log this out, but I'm just gonna go straight in and make an API call. So I'm going to use fetch as kind of the modern way to send a network request. And I'm just going to call some fake API, right? API.url. So for every click event, we're subscribing to this stream of clicks. And for every click event, we're going to fetch some remote URL. Okay, and we'll wait for the browser to reload for this. Okay, so we click and we make a network request every time, you can see. It's loading and it completes when we have a little tick. Okay, so what's the problem here? This is, this is something that we could just do with the add event listener, right? So this RxJS isn't adding a huge amount of value here. But what happens when our users get really, really keen and start spam clicking this button, right? Does our server have to deal with all that traffic? No, look, this is something that load balancers should deal with, that our backend should be able to cope with. But ideally, it's going to get into quite a confusing UI state if we've got 100 network requests being sent for the same thing all at the same time. So what I want to show you is how thinking about these clicks as a stream of events can help us by using some really quite high level programming concepts. So I'm going to come down here and say throttled click stream. And what I'm going to do is transform this original click stream by using the pipe function. And pipe is interesting, right? Pipe is a function which takes one stream and pipes all the events or all the elements of that stream through some, well, a pipe is a really good metaphor, actually. And so in this case, I'm just going to use a function called throttle time, and I'm going to set 1000 milliseconds. So throttle time is going to take all of our click events and only let one click event through every second. And so now let's have a look and see what this does. So we have throttled clicks and we have our original stream of clicks. Now what happens if we spam click here? Right, so we're still sending all of these network requests. And what I'm hopefully demonstrating right now is that pipe is what we call a pure function. Pipe doesn't go in and modify this original stream of clicks, you can see down here, we're subscribed to this original stream of clicks. And every time this original stream emits, we send a network request. It's sort of irrelevant that we've done this transformation and got a throttled stream. What we need to do here is instead of subscribing to the original stream, we need to subscribe to this throttled click stream. Okay, so this might seem a little slow for some of you, but I'm trying to build up as much intuition as we can so that when we dive into some harder exercises, it's going to seem really, really obvious what's going on. Okay, let's see why that hasn't loaded properly. Okay, so we've throttled the events, so we should be getting at most 1 click event a second. And there we go, I'm spam clicking on this, and we're only seeing 1 network request a second. Our servers are much, much happier. Okay, so I think that's as much as we can get out of this demo, other than saying that we can, of course, also subscribe to this original click stream and do whatever we like with it. We can, original click, and this would, every time we click the button, not just every 1 second, it would print out something in the console. Okay, anyway, so let's move on to a slightly more real world example. And let's talk about something that actually is a feature request that I've had from a client in the past. So we will check out, first of all, clear all that stuff and check out our new starting block. Okay, we'll just wait for this to rebuild. But essentially, the premise of this is that we have built some dashboard for a client, right? So it might have a graph, it might have a button, it might have a table, and I've got all 3 in this dashboard. You can see there here. And our client is maybe a bit slow, or maybe their users are a bit slow, and they don't quite understand what's going on with the dashboard. There we go. So with this dashboard, we've got all these different elements. It might get a bit confusing, and our client has requested this box at the bottom, which allows you to mouse over any one of these elements and just see some help text in the bottom. Now, anyone with a little bit of web programming experience, especially with frameworks, might be thinking, oh, that's a bit tricky actually. Where is this state going to be stored? So I want to show you how RxJS makes this actually really, really easy. So let's go through this step by step. And again, this use effect, this function is just going to be called anytime this page is loaded. This talk, it really isn't meant to be about React or anything. It's just slightly easier to show you things like network requests in a safe environment by working inside a framework. Okay, let's look at this example. So we have a stream of mouse move events. That's probably a good place to start. So I'm going to use from event. And here we can just say document, because we want to record mouse move events from all over. So this is mouse move streams. Cool. And let me see. After this, we want to pipe this, right? We want to transform this stream of mouse movements. And so the first thing we want to do is say element stream. So we're going to transform this stream of mouse movements. Move, not mouse over. I'm getting confused. So mouse move stream dot pipe, and again, pipe is just transforming this stream of mouse move events. And so each event is going to have an X and a Y coordinate. And so we're going to essentially, so map works here just like it does with an array. So if you have a stream of values, using the map function is just going to take that stream and apply a given function to every element of that stream. So in this case, we're going to use a really, really useful function called document.element from point, and just pass that our X and Y coordinates. So now what we have here is element stream is literally a stream of DOM elements. actually, let's use subscribe and let's just subscribe to console.log. And so for every element, we're going to console log it out. Let's pop open the JavaScript DevTools here and open the console. And so you can see that we're getting this huge stream of elements here. So we're hovering over the image, and every time I move a single pixel, we're getting the same image. So this is probably not great for performance, right? But now we're hovering over the button, we're getting this huge stream of mouse over button events. So let's do something a bit smarter here. RxJS gives us another amazing function called distinct until changed, which is helpfully auto filled for me there. So if I just add this one line in distinct until changed, what it should do is only show each new element. So for example, I'm hovering over this image, moving my mouse a lot, but it's not giving me any more events in the stream, right? It's not giving me any more image elements in the stream because it's not changed. So this is the power of one line of code in RxJS, right? So we don't have to write any code to check what the previous value was or anything like that. Distinct until change will do all of that work for us. So what do we want to do now? We want to have a look up here. And so I've just written this already because it's not very interesting JavaScript. But here's the default help text that we see, mouse over something to see help. And here's just a little object. It's so like a map in any other language. So the way I thought would be easiest to do this is just take each element's ID. We can assume that the ID of an element is unique. And just say for the ID graph, here's our text that we want to show in the help box. This shows a trend in data over time. For table, similarly, for important buttons, similarly. So we've just got three elements with IDs. What we can do is pluck out the ID from each element in this stream, and then from that ID, use help text by ID to fetch the actual text that we want to set. So let's do that. So we're going to use map again and say it's a function which takes an element, because remember, this is still a stream of document elements. And so if the element is null, so this is essentially like a base case we have to think about, like if we're not hovering over anything, we should just return default help text, right? So that's a smart thing. It'll just return mouse over something to see help. And so we can rename this element stream, because now that we're mapping it, we're not actually wanting a stream of elements. We're wanting a stream of help text stream. So if you're following this, what we should have in the console.logs is a stream of every new value that we should set for this help text. So if the element isn't null, this is kind of the interesting case, we should be able to return help text by ID and then just element.id. So we'll take the ID of the document element that we're hovering over, look it up in this table, and fetch the help text that we want out of there. Let's see how that works, and then we can plug it into our React world. Blah, blah, blah. Okay, element is not defined. Yes, of course, because we changed the name there. So help text stream. Okay, so this is all saying undefined. What's going on here? Help text by ID, element.id. Okay. If anyone spots what's going on and can quickly help me out, that would be very useful. We have to return it. Perfect. Yeah, thank you very much. Cool. Okay, so let's have a look in here. Awesome. Okay, so we're hovering over the graph and we see this shows a trend in data over time. We're hovering over this does an important action, the important button, and we get this does an important action. We hover over the table and this shows tabulated data. You can also see we're getting undefined there. And that's just because we're hovering over something which doesn't have an entry in this help text by ID, but which is an element. So for example, I think this is just a section element. So here I can also just add in an or default help text. Okay, awesome. So let's have a look. Brilliant. Okay, so this looks just right. Now let's plug this into React. So now we have a stream of help texts. Let's just assume that we have some function set help text. And in fact, here we have const help text equals default help text. That's just being rendered here. In fact, we can just pull this out into state. Set help text, set help text, and use state. Again, this is more React code than RxJS code, so don't worry if you're not familiar with this whole use state stuff. But essentially, we're subscribing to this stream of new help texts, and for every one, we're setting the help text. So there we go. Every time we hover over a new element, you can see in the bottom left-hand corner here, we get a new help text. So there you go, a useful client feature written in what, like 10 lines of code. There you go. Okay, so drop any questions you have so far in the chat, but otherwise I'm going to move on. So let me get that ready. So we're going to do something a little bit trickier now. We're going to talk about multiple network requests. So multiple network requests is kind of typically quite a tough problem. I think this is the point where I have to restart Yarn. There we go. Such is the scary bit of doing git checkout every time I want to change demo. But anyway, so what I want to do is essentially talk through how we marshal different streams of events and merging those streams together. So in this demo, we're going to be sending 3 network requests for each button. Yeah, there we go. Great. Okay, so we have 2 buttons here. We have a green button and a blue button. And every time we click the green button, we want to be sending 3 network requests to some green API. And every time we click the blue button, you get the picture. So the interesting bit here is that there's multiple different ways to combine these streams together. And we're going to go into that in a bit more detail, but let's get something basic down first of all. So we'll hide this terminal again. Okay. And first of all, we'll just get streams of the clicks from each button. So we can say green clicks from event green button. And so again, this is just a stream of the clicks on the green button, and the same with blue clicks is from event blue button. Great. And so I'm going to merge these streams together because essentially we have one function that's going to send network requests. Actually, I passed it in here, right? So this is a little bit of a chicken and egg problem to explain this demo. We need to assume something that we don't yet quite understand. So take a leap of faith with me. Here's what we're going to assume, that we have some observable called some function called 3 network requests, which is going to return an observable, which when we subscribe to that observable, will make 3 sequential network requests and send us, the subscriber, the responses of those requests. So one thing to note is that observables can do stuff when you subscribe to them. So far, we've only subscribed to things like click streams, where essentially clicks are happening anyway, regardless of whether you subscribe to them or not. But observables are just like any function in this way, right? So when you subscribe to them, they can do stuff. They can set up network connections. They can connect to a WebSocket server. you know, conceptually, they really are just functions which can send you streams of values instead of just one return value. But anyway, this three network requests will send us the responses of those three network requests to some URL that we specify. So we're assuming this exists. But let's write something which anytime we click these buttons is just going to subscribe to this this observable. Okay, so let me pull up my code again. Okay, so a click stream, first of all, we're just going to merge together, and we can use the well-named function merge for that. Green clicks, and actually, so we can merge together green clicks and blue clicks, just like this. Okay, that's all you would need to do. But in order to differentiate these, I'm actually just going to map them to the URLs that we should be sending a network request to. So for any stream in the green clicks stream, whoops, that's a typo. For any stream in the green clicks, we just want to map this to, I'm going to use map2, again, a very well-named function, api.green. Sure, why not? It doesn't really matter, it's not a real network request, spoiler alert. api.blue, and make sure that's actually a string. Cool. So now we should have, and we can log this out, right? So we can do clickstream.subscribe console.log. Let me pull up the tools here. Cool. Yeah. So every time we click on the blue button, we get this string, which is api.blue, sent through to our subscriber. And every time we click on green, we get this string of api.green set through to our subscriber. Hopefully that's clear. And it's clear that we're just merging those two button event streams together and mapping each of their values to the URL that we want to call. Okay, but let's actually do something now. So we have this merged stream, clickstream.pipe. And again, just pipe all these URLs into a pipeline. And so we want to map this URL to, what do we want to map it to? Well, we want to map it to whatever this three network requests returns, right? So let's see what happens. Three network requests URL. No, you know what? This might be a little confusing straight away. So let's do it in subscribe here. So every time we click subscribe, every time we click one of these buttons, an event is going to propagate through this pipeline and end up in our subscriber. So so here we have, you know, a URL is going to come through, and let's just call this three network requests URL. And why not just console.log what the return value of three network requests is, just so we're not hiding anything behind smoke and mirrors. So we have this observable, right? So we can say three network requests, this function accepts a URL and will return an observable. And remember that previously I said observables can do things when you subscribe to them, but we're not subscribing to this one yet. So why don't I subscribe to this? So three network request URL is an observable. So I'm going to call subscribe. And so this is getting a bit gnarly, right? So we have our click stream has been subscribed to, and for each URL in this click stream. So actually, this is a bad name, right? So this is a URL stream, not a click stream. But so for every URL here, we're creating this new observable and we're subscribing to it. And then for each thing that comes down the pipeline in this new observable, we're going to see what it is in console.log. Okay, awesome. So here we can see two things. We can see, first of all, now that we've subscribed to this three network requests URL, now that we've subscribed to this observable, we're actually making these network requests, right? And the second thing is that we subscribe to it, and for every element that comes back, we're doing a console log. And so by subscribing to it, we're getting all three responses. So this is how I described it earlier. But the interesting bit here is if I click blue, then green, we have these kind of interlinked or interweaved responses, which is kind of confusing, right? If this is, say, switching between tabs, you switch to the green tab and then you change your mind and you switch to the blue tab, but here you're still getting a response that's meant for the green tab. So do you just ignore it somehow? Do you store what your state is in the app? It gets really confusing. So let's do something to try and mitigate this, right? So I want to show you some RxJS primitives which allow you to merge streams together more smartly and to deal with what we call higher order streams. So let's go one step at a time, right? So let's remember that providing this function, this URL acceptor function, it's just called next, right? WebStorm is labeling this as next. Providing this function is just saying that every time we do something, every time we get an event in the stream, we should just call this function on it. So that sounds pretty suspiciously like map. So let's go ahead and move this into map. So URL stream.pipe, and we're going to map the URLs to this, and we're not going to subscribe to this just yet. So let's make that a little bit clearer. So what are we doing here? We have our stream of URLs. We're mapping each URL to this observable, and then we're subscribing to this stream of observables, right? So actually, observables. Okay. So we're getting the same result as we had before, right? We're clicking the green button and we get a new observable. So this isn't very useful and it's not actually subscribing to these observables, but we're getting somewhere. So what I want to show you is that now we have a stream of observables. It's essentially like, if you think about it as a type, we have observable of something. Right, so let's take a really quick detour and think about how we've seen this pattern elsewhere, right? Because this is really abstract, but it is actually something that we've probably seen before. So let's remember that JavaScript arrays have this problem too. We have arrays of arrays, we just call them 2D arrays. And because observables are these crazy things which do things when you subscribe to them and they spit out values over time, this can get a bit twisted, but here's what it might look like in JavaScript, right? So let's say we have an array of countries, and that just looks like country. This is kind of pseudo JavaScript, but whatever. And we also have this function called get cities, which is, it will just take a country and it will return city. Right, so we have these two things. And so we can imagine that countries might be, Japan, Brazil, UK, and then get cities might take the UK and return, London, Manchester, Birmingham. So what happens when you do countries.map get cities? Ideally, one thing we might want is to say, all cities in world equals countries.map get cities. Right, so this is kind of something we might want to do, is just collect all of the return values of get cities for every country we have. And what we might expect is that we have, city, etc. But what we actually get in this case doesn't look very much like that. It looks like a nested list. So it looks like one of these for every country, which isn't super useful. And so what we have, what we've found in JavaScript is that there's a useful function for this, right? Which is let's say we call this like nested or something. We can do nested.flat. In other languages, it's often called flatten, but in JavaScript, it's called flat. And what that will give us is essentially something that looks a bit more like this. So this is cool, right? So we have this pattern of doing countries.map, get cities.flat, and then we'll get this list of cities, all the cities in the world. So if we wanted to be really fancy, we could call this nested thing like a higher order array, or like a 2D array or something, but it's not really too tricky a concept. It's just the idea of going from array of cities to just an array of cities. And the same thing is true of observables, right? So we go from observable of, and in our case, it's like a response to a network call, right? And all we want to do is get back to this case where we just have a single stream of responses. So what's the RxJS equivalent of flat? Well, I'm going to answer that question, but I also want you to think about this slightly lesser known method that JavaScript has, which is super useful, because essentially this map and then flatten is such a common paradigm that we've actually just created this new method called flatMap, get cities. And actually this does map and then flatten in one step. Right, so that will return exactly the same thing as here. Okay, hopefully that's clear. So we've done a brief digression into flattening and flatmap, and these are really useful things to bear in mind when we're talking about nested streams. Right, it's not a crazy idea. It's just kind of a natural consequence of having data that's very slightly more complex. So anyway, what we have here is observables stream is a stream of observables. So it looks like this. So where's our flatten, right? We want to try and flatten these out. So we just get a stream of responses, and then we want to subscribe to those. So RxJS provides us with this function called merge all, which essentially does the same thing, right? So let's look at what merge all does. We've got a stream of observables. We're going to merge all of those observables into one, and then return and then subscribe and log out all of the return values. So there we go. So we have 3 responses from green, and we have 1, 2, 3 responses from blue. And if we click them both, they will both kind of interweave in the same way. And the difference, the really key difference between our arrays being flattened and our observables being flattened is that arrays are just synchronous sequences of values, right? There's only one way to flatten this list of cities into this 1D list of cities. But observables happen over time. And so what we have is the case where, observable A kind of emits like A, but in the meantime, observable B might emit here. So observable B, B, B. And this might be our green responses, and this might be our blue responses, for example. So we'll call these G. And so RxJS gives us these tools to merge them together. So what we've done is essentially created this one, which looks like this, right? So we're merging all of, this is one observable, this is a second observable, and we're merging them together into a single stream of values. But what we could do is say, as soon as we get to this first blue, as soon as this second observable emits anything, we can unsubscribe from this first one. So what that would look like is just like this. You can see that this is kind of so this one is the behavior of our like merge all function, and this one is called switch all. And there's a few others, right, as well. So there's one called concat all, where we have to wait for the response of the last element. We have to wait for the first observable to complete before we even get to the second observable. And that looks pretty much like this. And that we call that concat all. So these are kind of, I don't expect anyone to just remember these. There's documentation for that reason, but these are really, really powerful concepts, right? So we're pulling together these streams of values, and we're merging them together in different ways. So for this example, let me show you what switch all does, because I think it's a really useful case here, and let's make sure to import it. Okay, so we click green, we make 2 network requests, and then I clicked blue there. And you can see that we're not receiving any more green network requests. In fact, this existing network request was cancelled. You can see I've shown that with a little cross there. And this isn't just kind of some fun demo. I mean, it is, but this isn't just kind of fantasy land. RxJS actually provides tools to do this. So the 3 network requests is implemented using an RxJS function called Ajax. And that Ajax can just send a network request, but it can be cancelled as soon as you unsubscribe from this. That network request will be cancelled in flight. And that's actually quite a tricky thing to do in regular JavaScript. It involves kind of using this fetch abort handler API, which is still kind of funky. But yes, so in kind of one line of code, and I appreciate I'm probably moving quite quickly, but one line of code, we've expressed so much about what we want our program to do. And this is kind of a theme you see with RxJS, right? That you have an incredibly dense amount of information in one function call or one line of code. It kind of reminds me of regular expressions or functional programming more generally, where you can be really, really expressive in quite a short space. And you don't have to rewrite all of this functionality. So very, very quickly, what I showed you with arrays is that we can map and then flatten. And because ES6 is nice, it gives us this extra function called flatMap, which does pretty much these 2 steps in one. So I just want to show you quickly, there is actually an equivalent here, which does map and then switch all, and it's just called switch map. Much like map and then flatten is called flatMap. There's also merge map, concat map, etc. for these other options. And there's probably others that I'm unaware of as well. But switch map is what we want for this one. So in one line of code, I guess just to recap, we've triggered this 3 network requests function, which creates an observable and sends 3 network requests. But crucially, when we start sending another URL through, it cancels all of the previous ones. Okay, so I think we've pretty much exhausted this. I can briefly show you how the 3 network requests might look. So it might look something like 3 network requests, takes a URL, and it just uses this function concat. So remember, these network requests are sequential. So concat and then Ajax URL. Whoops. Ajax URL. Ajax URL. So that's how it would look essentially. It's really, really simple. It's just not the sort of thing that would be explainable without talking about these things previously. So concat is essentially just a way of calling concat all, but outside of the context of pipe. So lots to take in, I know, but hopefully you can see that RxJS is a really, really powerful tool. I'm going to end on quite a fun demo that's hopefully a little bit easier to take in. I know we've gone through quite a lot here, but I'll be happy to answer any questions either in the chat or message me afterwards. I'm just Bede on Discord. Yes, so I'm going to switch to my final demo. Start. Okay, nice. That was almost unreasonably smooth. Wow. Okay, so again, use effect. We're just calling this code every time the app loads. And so we want to make something that lets the user draw on this canvas. So think about what events we might want to listen out for. Do we want to listen out for mouse moves or mouse up or mouse down? In this case, I'm actually going to use the pointer API because it makes things much easier on things like touchscreen devices. Okay, so what you're going to see actually is most of this code is just boilerplate dealing with HTML5 canvases. The actual business logic of RxJS is about 5 lines of code, which I find crazy. But let's do it. So let's set up a context, which is canvas.getContext2D. This just gives us something that we can draw on. We can say context stroke style is white. We're drawing on a black background. Line width, call that 5 or so. And we're also just going to set image smoothing enabled because it makes things look a little bit nicer. So let's just write out a couple of utility functions. So first of all, we're going to do this function, which is move without drawing. So this is quite simply, we're just moving to a point on the screen without drawing a line at all. So that's what it looks like in Canvas. I've just extracted these X and Y points. You'll see why in a second. And then also another utility function to draw line to point. And again, that's just going to take an X and Y coordinate, and it's going to do a couple of things. It's going to do line to, and then it's also going to call stroke. Okay, so easy enough. Two utility functions. Now let's talk RxJS. So first of all, we'll just grab streams of each of the events that we think are going to be useful. So we're probably looking for the pointer going down, so it's the mouse clicking down, if you like, or the finger going down on a touch screen, moving, and then being lifted up as well. So let's get streams for each of those. Pointer down from event canvas pointer down. You know what always catches me out about these event names is that this isn't camel case, right? So many bugs are really hard to find as well. There's no error thrown if you write it like this. Anyway, sorry, digression. Pointer move from event canvas pointer move, pointer up from event canvas. That's a problem with the browser spec, by the way. It's nothing to do with RxJS. Anyway, so we have our 3 kind of streams of events. So let's think about some interesting ways to combine them. The one that's going to be useful here is a single, is essentially when you subscribe to this, it's going to give you a stream of points on the screen in an unbroken line until the pointer is raised. So we're going to say single line stream is the stream of pointer movements, and we're going to use this really handy function called take until, which allows you to take from this stream the pointer movements until this stream emits a value. So I'll just make sure both of those are imported. So again, this is kind of very terse logic, and it might if you're used to writing things like graphics code, it might seem almost unreasonably short. But yeah, so this is what it does. The pointer movements in a stream until we get a pointer up movement, a pointer up event rather. Now let's just see what the string of lines would look like. So we can say pointer down. Whoops. So as soon as we get a pointer down event, we're going to start our pipeline. And so what I'm going to use here is switch map 2, which again is just kind of, we learned about switch map in the previous one, and we could do something which looks like this. Switch map that doesn't care about its input value and then returns a value. Switch map 2 is essentially the same thing, but it just gets rid of that function. And switch, yeah, essentially it switch maps every pointer down event to whatever observable I pass in here. And so in this case, the observable is going to be single line. So this is very, very terse, but I'm hopefully going to show you that this works. Subscribe, draw a line to point. Yes, of course. So here's what we have so far. So we can spot one tiny problem here, which is that the lines are joined up whenever I move my mouse cursor without keeping it down. And so actually, this is a really, really easy problem to solve because we defined this move without drawing function earlier. And so I'm going to use our very last RxJS operator of the day called tap. And tap is super useful for debugging actually, because it just essentially tap runs some kind of side effect. It has no effect on the stream whatsoever. It's just, value, and you can console log that value. And it has, it doesn't care about the return value of this function at all. It's just a really good debugging tool. Actually, it's great for us as well, because what we can do is tap these pointer down events. And every time we get one of these pointer down events, we want to just move to that pointer down coordinate without even drawing a line. So we're going to tap, move without drawing, make sure to import tap. Okay, so let's see what this looks like. Okay, it's looking good. All right, so we have a working Sketchpad in, these barely count. And this is kind of what, like four or five lines of useful RxJS code. It's again, I really want to emphasize, like, this is as close as I can get to proper functional programming with all kinds of crazy functional abstractions in JavaScript, but that work over, values that have effects over time, values that depend on each other, streams that you merge together. I'm going to leave you with a couple of exercises should you want to carry on playing around with RxJS. All of this code, by the way, both the starter branches and the completed code are all going to be on GitHub. I'm going to post a link to that somewhere, probably in the general chat. But two exercises I think might be quite useful are changing the color of the line every time you put your pointer down, and trying to change the color of each line as it's being drawn, point by point, or changing the whole line. I think it's a really useful exercise. But okay, I think I'm pretty much very nearly out of time, and pretty much out of material. So thank you all so much for joining. And hopefully you've learned something. Feel free to ask me any questions.